In this activity, we will be learning how to make a clinometer. The objective of this activity is to make a clinometer which is used to find the height of a tall object or to find the distance between two objects. Let's see what is the concept in hand. Basically, a clinometer is used to find two things. One, the angle of elevation. The second one is the angle of depression. Whenever we are standing on the level ground like this, at this point, suppose P, and observing something vertical like a building or a pole or a tower, the top of the tower or the vertical object is A, and we are watching along the line AP. This line AP is called the line of sight. The angle which the line of sight makes with the ground, this angle is called angle of elevation. How do you measure what angle the line of sight makes with the horizontal? That angle is measured by the instrument called clinometer. So we measure the angle of elevation using the clinometer. On the other hand, if you are on top of some vertical object like standing on the top of a building at point P, this is the ground level, and you're observing something on the ground at point A. So the line of sight will be like this, and the angle made by this line of sight with the horizontal through P, this line, this angle is known as angle of depression. So how do we measure the angle of depression? Again, the use of clinometer. So if we know how to make a clinometer, then we can measure the angle of elevation and angle of depression, which are used to find the heights and the distances between objects. The material required for making a clinometer are a protractor, straws, thread, weights, pin, geometry box, etc. Some basic things are also required which are not mentioned here. Let's see how these material can be used to make a clinometer now.
In this activity, you first need to take a protractor and fix a straw. You can see the upper part of this is a straw. We have fixed it on top of the protractor like this, and in the middle of it we have fixed a nail through which we have suspended a weight. So this string, if you rotate the protractor, the string will be vertically downwards only, and it will point out towards some angle. This arrangement is now used outside, where you have to stand and point the straw towards the top of a tree. So you see carefully, if you see through the straw, you are going to see the top of the tree, and therefore the angle which the vertical string makes with the line of sight, that angle can be found out very easily. And also, if you draw a horizontal through this point of the straw, you can find this angle also. So once you know this angle and this angle, you know both the angles can be formed. The angle which the protractor shows is this angle, and since we have a right angle triangle being formed like this, this is 90 degree here, this is the angle measured by the protractor, the string, and therefore the third angle will be the angle of elevation. This is known as the angle of elevation. Now once you know this angle of elevation theta, this height, this part of the tree, the height can be found if you know the horizontal distance between you and the tree, that is d in this case. So taking the mathematical treatment, tan theta will be equal to perpendicular upon base and therefore the height of tree will be equal to your own height P, that is this part, and add the tan theta, the value of tan theta, that is this h is to be found out from here. So h is d times tan theta. So if you put all the values here, you can find the height of the tree, and that completes the activity.